How do you feel about graphing?
Pretty easy.
Pretty easy? Well, I guess we can probably just skip it then. I got it covered.
I wanted to do it, you guys not, but we couldn't do it.
So there's a little bit to graphing that we have to do before we get into graphing equations and stuff. We're going to start off by naming the thing. You know what the name of a piece of graph paper is called? A piece of graph paper. It's got a special name, and it's not piece of graph paper. It's called the rectangular coordinate system. Rectangular coordinate system is what us modern folk call it, but if you really want to impress the ladies at your next math party, you can call it by its given Christian name, which is the Cartesian Plane. The Cartesian Plane is what you call it when you really want to impress people with your math knowledge / scare people off with your math knowledge. And the reason it's called the Cartesian Plane, was originally called the Cartesian Plane, is because it was invented, or I guess created, by a Frenchman named René Descartes.
Will this be on the quiz?
Well, no, but it might be on Final Jeopardy, so it never hurts to know. René Descartes was the guy who invented the Cartesian plane. Your textbook calls it the rectangular coordinate system, but I will refer to it usually as the Cartesian plane because I really like to impress people by how very, very smart I am. So I passed out to you when you walked in an example of these Cartesian planes. They look like this. And let's go ahead and see if you can name the pieces of this. Do you know, first of all, what this line going right through the middle like that is called?
The x-axis.
Very good. That is called the x-axis. And using your incredible powers of deduction, could you then name what this line is called, the up and down one? That's called the y-axis. And this is why in math we use x and y's so often, because they're coordinates, x coordinates and y coordinates. So the x-axis and the y-axis. And the place where the x-axis and the y-axis intersect, right there in the middle, do you know what that's called?
The origin?
That's called the origin. Very good. And the coordinates of the origin are 0, 0. And the reason the coordinates are 0, 0 is because that is 0 on the x-axis and 0 on the y-axis. That is the starting point of both the x and the y-axis. Now you may be thinking to yourself, hold on a second, what do you mean starting point? How can it start in the middle? It goes in both directions. Wouldn't this be the starting point? And the reason why this is the starting point is because if you go in this direction, you have positive x values. And if you go in this direction, you have negative x values. On the y-axis, same deal. If you go up on the y-axis, that gives you positive values. And if you go down on the y-axis, that gives you negative values. A Cartesian plane is divided by those axes into 4 sections, and we call those sections quadrants. So there are 4 quadrants. And the names of those 4 quadrants are Jeff, Franco, Chantil, and Jorge.
Is it negative only in that little
Right here?
Yeah.
This is where they're both negative.
Okay. That's what I
Feel like you were asking questions over the name of my joke, and I don't appreciate that. The quadrants are named Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. I'm sure there is a great mathematical explanation for why people write these with Roman numerals instead of the number 4, but I do not know what that explanation is, and so I will make one up now. It's because the Romans stole this when they went to war with the French. So the observation you made is, hey, that quadrant, and now that we know the name, it's quadrant 3. Quadrant 3, everything's negative. That is exactly right. Which quadrant is everything positive in? Quadrant 1. So let's go ahead and write that out in our notes here. Quadrant 1, all positive. And quadrant 4 is all negative. Great. So the other two quadrants, that would be quadrant 2 and quadrant 3, have got a little bit of everything.
You said quadrant 4 is all negatives?
Oh, sorry, you're right, quadrant 3. All right, I got carried away. Quadrant 3, all negative. Quadrant 2 has got a little bit of everything. What's happening in quadrant 2? We got one positive and one negative, right? Which one is negative?
The one that's horizontal.
Which is the x. So quadrant 2 has negative x, but positive y. There we go. And quadrant 4, which despite what I wrote on this paper is not all negative, has the opposite. Quadrant 4 is when you have positive x's but negative y's. So it's possible to have positive x's. That's like when you guys are still friends. Positive x. Fictional in real life, but they totally exist in math. Cool. So what we're going to start off with is practicing how to graph just points. If I give you what is called a coordinate, and a coordinate is when I give you an x and a y number, where does that go on the graph? Okay. So a coordinate is always in the form x comma y. Meaning the x coordinate comes first and the y coordinate comes second. So the first number is telling me how far you go left and right. And the second number is telling me how far you go up or down. From, I should specify, from the origin. We start at the origin. Okay?
Is that for y?
That's for everything.
Oh.
So far, so good? All right, here we go. Let me give you a coordinate. There's no fancy way to read that. You read that coordinate as -2, -5. Before we do anything else, can you tell me which quadrant -2, -5 is going to be in? Why? Because it's all negative. The x is negative and the y is negative. So this is going to be in quadrant 3. So here's how I do it. On my Cartesian plane, I start at the origin right there at 0, 0. And the first number that I look at is the x coordinate, which was -2. So from the origin, I am going to go 2 places in the negative direction. If you go back and look at our original diagram, negative x's are to the left. So I'm going to start at 0, 0, and I'm going to move 2 spots to the left. Okay? So starting at 0, 0, 1, 2 spots. Now I'm not going to make a mark there because that's not where my point is, but that right there is 2 spots to the left. Then what's the y? -5, and if you look at the original diagram we did, negative y is down. So I'm going to count down 1, 2, 3, 4, 5, and that is where I'm going to do my point, -2, -5. There you go. You graphed your first point. It's a big moment.
You don't count the y at the x-axis. Don't count that. Below the-
All right. How about this one? Zero, -4. Which quadrant is that one going to be in?
Quadrant 3.
Uh-oh.
0, -4, 2.
Oh, I'm hearing 2 and 3.
Two.
If it makes you feel better. Huh? Well, that is an interesting thing to say. One's positive and one's negative, because now we got to answer the question, is 0 a positive number?
Right down the lines, you stay there and you go -4 to the whatever negative is that, which is quadrant 3.
No.
0 is not a positive or a negative number. So 0, -4 is not in any quadrant. 0, -4 is on the y-axis, which is not in a quadrant. So what that means is, from the origin, right here at 0, 0, the first number I look at, x, is how far I go left and right. My x is 0. I don't go left and right at all. I stay right there, 0 left and right. And then the y is -4. That means down 4. So down 1, 2, 3, 4. So if you said quadrant 3, you were close. If you said quadrant 4, you were equally close. It's right on the line between 3 and 4, which is called the y-axis. All right, let me see if I can really bake your nuclear.
These are awesome.
2 2/3 and 4 1/2. Question number 1, which quadrant do we expect it to be in?
Positive.
Quadrant number 1, because they're both positive. That's exactly right. So I want to count over 2 2/3 from the origin. Which direction, left or right?
Right.
To the right, because it's positive. Now here's the issue. I don't know where 2/3 is. So I'm going to estimate. There's 1, there's 2, there's 3. Now I know if I hit 3, I've gone too far. So I'm going to go a little bit in front of 3 and call that 2 2/3. And then I'm going to go up 4 1/2. So up 1, 2, 3, 4. Here's 5. So 4 1/2 should be exactly in between 4 and 5. And that point right there, I'm going to call 2 2/3, 4 1/2, which is in the first quadrant. Let's do one more of these. -1, +4. So I have a -x and a +y. Which quadrant is that? That is quadrant 2. Very good. So, from the origin, where do I go?
To the left.
1 to the left.
You going up 4?
And going up 4. 1, 2, 3, 4. And that's -1, 4. In quadrant 2, just like I expected. So far, so good? Okay. There's one more thing we're going to do before we start graphing these for real. Go ahead and set your graph to the side. One more thing that we're going to do before we really get into this, and that is answering this question. Is an ordered pair, oh, I should specify ordered pair is another name for that coordinate. Is an ordered pair a solution? I suppose if I really wanted to be good with my math vocabulary, I would say the whole thing is an ordered pair, and there's the x coordinate and the y coordinate of the ordered pair. It's a hefty amount of vocabulary. But learning those words is a small price to pay to be the most popular kid at the math party. Now, when I say, is it a solution, yes or no, here's what I mean. I'm going to give you an equation. Something like that. Now, I'm going to tell you right now, our goal by the end of the night is for you to be able to take that 5x plus y equals 15 and graph that on a Cartesian plane. That's our goals. By the end of the night, you'll be able to do that. We'll see how it goes. So, before we get there, though, confidence, you got this. The question I want to answer is an ordered pair a solution. I'm going to give you a set of coordinates. I'm going to go ahead and give you 3 of them. There's one. There's one. And there's one. My question is, are any or all of those solutions to this linear equation? Yeah, I don't know is the correct answer right now. I don't know, could be. How can I tell? This is what you do.
Well, you get y by itself. What is by itself?
Right. Actually, I don't even have to do that much. Recall that in an ordered pair, the first number is the x and the second number is the y. So if I wanted to check this coordinate right here, let's try 1, 4 first. That means that x equals 1 and y equals 4. So what I'm going to do is take this original equation, 5x plus y equals 15, and I'm going to replace the x with 1 and the y with 4 and see what happens. So instead of 5 times x, I'm going to do 5 times 1 plus, and instead of y, I'm going to do 4 equals 15. I don't even really have to do any algebra here. I just got to simplify the left side. 5 times 1 is plus 4. So what I end up with is 9 equals 15. Does 9 equal 15? No. So that tells me 1, 4 is not a solution. Okay, let's try the next one. The next coordinate was 2, 5, which means x equals 2 and y equals 5. So I'm going to take my original equation, 5x plus y equals 15. I'm going to do some substitution here. 5x plus y equals 15. All right, let's solve it. 5 times 2 plus 5. So I end up with 15 equals 15. All right, use your calculators if you need to. Does 15 equal 15? Yes, it does. So that tells me 2, 5 is a solution. Now, when I say solution, what am I even talking about? I mean, yeah, the numbers work in the equation, but what does that even mean?
It could be graphed, right?
Be more specific, because both of these could be graphed. I could put 1, 4 and 2, 5 on a graph, couldn't I?
Yeah.
What does it mean when I say it is a solution?
For the equation.
For this equation, I told you the goal here is going to be to graph this. If I were to graph 5x plus y equals 15, what do you think it looks like? What shape do you think is made when I graph that equation?
Should be a U.
Could be. If it was a U, and I am not saying that it is, but if it was a U shape, saying that something was a solution means that this point is on that shape. If I put this on a graph, this shape, whatever this makes, goes through the point 2, 5, and it doesn't go through the point 1, 4. This is useful information to us because when we graph something like this, the way that we're going to do it is we're going to get a couple of points and connect them. So I got to know which points can I put on the graph and which ones can I not. That's what it means by it's a solution. When I graph it, it's going to go through that point. Let's try the last one, which is 0, 15. So that means x equals 0 and y equals 15. Okay? Back to the equation. 5x plus y equals 15. So 5x plus y equals 15. All right, let's solve it. 5 times 0 plus 15.
15.
So we get 15 equals 15. Lord have mercy, it's true. 15 does equal 15. Which means 0, 15 is a solution. So if I was going to graph that, if I wanted to graph 5x plus y equals 15, one way that I could graph it is I could pull out my sheet of graph paper. I could put one point at 2, 5. I could put another point at 0, 15, and then connect those 2 points together. If I did that, what shape would I make? I would make a straight line if I connected 2 points. And as it turns out, this is a straight line. You said a U shape, which is true if...
I think I'm going a little maybe ahead.
You're a little ahead. We're going to get there, don't worry.
Okay.
But I'll go ahead and talk about it right now. A U shape is when the x is squared. When x is to the second power,
Okay,
then it makes the U shape. Yeah, we're actually going to get to that in just a few minutes. You're just a little bit ahead of me. Stop showing off.
Like I said, I wanted to graph, but
I know. You've been waiting for this for weeks. I can't wait till we graph. I know.
after that
I'm excited
test,
too,
I was
buddy.
like, you're
After that
graphing it up.
test, he's like,
I'm trying to click
graphing.
on it. Well, let me.
I'm sorry about that.
Release
Sorry
it.
about. You know what? Tonight you can graph. Tonight you can graph. Okay. Now let's do what is going to be the most useful piece of this for you. Okay. There's my equation, the thing that I want to graph. And here's what I'm going to tell you. The x coordinate of one of my solutions is 2. What is the y coordinate?
Wouldn't you have to just solve it?
I will have to solve it. But when I say the x coordinate is 2, what exactly do I do here?
You replace it.
I replace this x with 2. So I get 2 plus 2y equals 6. Now I got to actually do a little bit of algebra. Now I got to figure out what y is. So what do I do? Minus 2 on both sides. That's a good plan. Six minus 2 is 4. Yeah, divide both sides by 2. And I get, I think you said dose. I'm sorry, that's incorrect. The answer is 2. Which means the solution would be 2, 2. 2, 2, meaning if I were to graph this, one of the points it would go through is 2, 2. Everything we are going to graph tonight, and in fact, everything that you are going to graph in this entire class is going to be a straight line. In the next semester, you'll graph the curves. So we're going to learn to identify which ones are curves, but we're not going to graph them until next semester. I say that to you because I cannot graph a line with 1 point.
All you need is 3, right?
Actually, you can get away with 2. If you have 2 points, you can draw a line through 2 points. I'm going to have you do 3 because 3 is better, but the minimum requirement is 2, which means I need another point. I said 2 comma something, and we got one of the points. Let's get another one. This time let's do it a different way. This time let's say I want the y to be negative 3. What should the x be?
Wait, so this one's 2, 2, right?
One of the coordinates is 2, 2.
Okay, so the 2 up there, you're not going to put a 2?
That's right. This one, I'm back to x now.
So the answer is 2 minus 2 and 2. But that up top in the middle, is that, you're not gonna put 2 there? Where it's
Are
the
we
space?
looking for that too?
No. One of
Problem
the
done?
oh no, okay. One of the coordinates is 2, 2.
Okay.
But I gotta have another one. So I'm giving you this to say let's go find another one.
What's the one on the left? It's already taken care of, right?
This one's already taken care of. 2, 2 is the answer. Now we're doing another one. Let's go find another one.
Alright.
Because I gotta have at least 2 in order to graph I have at least 2 coordinates in order to graph this. So I'm gonna do x plus 2y equals 6, only now I know a y. The y is negative 3. So I'm gonna replace the y with negative 3. X plus 2 times negative 3 equals 6. Yep. Do a little bit of arithmetic there. 2 times negative 3 is negative 6. So x plus negative 6 equals 6. That's right. Add 6 on both sides. And I get x equals 12. So that means the other point is 12, negative 3. So if I wanted to graph this, I could put a point on my Cartesian plane at 2, 2 and at 12, negative 3 and connect those 2 dots, and that would give me my line. What I want you to notice about the way that we found those 2 points is that this wasn't a special number. I just made that up. I just said, hey, I want the x to be 2. And then over here I said, hey, I want the y to be negative 3. You can pick whatever you want for one of the coordinates. And then you use algebra to find the other.
Unless they show us on the online.
Unless they say, well, I mean, they'll do the same thing I did. They'll say, hey, your x has to be 5. What's the y?
Oh, okay.
But you can make up the first point.
Okay.
You can say, I want the x to be whatever, and then you go find the y that works with it. Let's do one more of these because this is really important. Let's do one with fractions because everybody loves those, right? And just so you kind of get the idea, let's do one of each. Let's do one where we get the x coordinate and one where we get the y coordinate. So it doesn't matter. Let's start with x. Megan, just make up a number for x. Anything you want.
9.
9. Great. So one of our coordinates is going to be 9 something. And then Bryce, make up a number for y.
5.
5. Great. I can make up one of the 2 coordinates, then I have to actually solve for the other one. So let's do the 9 first. This is an x of 9. So that means I'm going to come over here and replace that x with 9. Did you do that on purpose? Did you pick a number that was going to work really well with 1/3? You are so smart. So y equals 1/3 times x, and it just so happens that our volunteer, and by volunteer I mean voluntold, picked a number that multiplies perfectly by 1/3. What's 1/3 times 9? 3. Perfect. Oh my god, you had to have planned this. What's 3 minus 2, kids? 1. You picked the easiest possible problem. Fantastic. So that means that one of the coordinates is going to be 9, 1. Now let's find the other one. We just made up y. So we're going to replace the y here with that number. So instead of y equals, we're going to do 5 equals 1/3 x minus 2. And now, since the x was missing, that's the thing we're going to solve for. So what should we do? Add 2 to both sides. That gives us 7 equals 1/3 x. Now here's where I'm being kind of tricky. How do we get rid of 1/3?
You times it by
Upside down.
Times it by 3. Very good. So this side gets multiplied by 3. And this side gets multiplied by 3. We get 21 equals x. So the other coordinate that this one goes through is 21, 5. So on my graph, I would put a point at 9, 1, and I put another one at 21, 5, and then I would connect those two dots.
But if it's straight line, she goes through all 4 of those.
Say it again?
Well, if you're gonna make a straight line, and all 4 of those numbers should be in line, right?
All 4?
Wouldn't it?
Like 1, 2, 3, 4?
Oh, no.
This is one ordered pair, and this is one ordered pair. So these are 2 points on the graph.
Question.
Yes, sir.
So on the negative or the 1/3 x times 3.
Yes, sir.
How you got x would be putting 3 over 1, right?
Yes,
You put 3 over 1 just so those two can cancel.
that's exactly right. We multiplied by 3 just so the 1/3 would cancel. Exactly. So this is one of the ways in which you can graph a line. Now, maybe you're seeing a problem with the way that we're doing this, which is that the 2 ordered pairs we got just now was 9, 1 and 21, 5, and the graph paper that I gave you does not go that high.
Yeah.
The graph paper I gave you stops at 8. So 9, 1 will not fit, and 21, 5 will definitely not fit. So when we're picking numbers to graph, we have to be a little more discerning than that. We want to pick numbers that are going to be small enough to actually fit on our graph paper. So that's one thing that you need to keep in the back of your mind is, I want points I can put on the graph, but they need to be small points so they'll fit on the paper. Does that make sense? Okay. So we talked very briefly about this. Everything we're going to graph is going to be what is called a linear equation. And a linear equation, if you ever get mixed up on what it is, the answer is right there in the word. It's called linear because it is a line. The shape is a line. There are only 4 kinds of lines it could be. You could have a line that goes up from left to right. You could have a line that goes down from left to right. You could have a completely flat horizontal line, or you could have a completely flat vertical line like that. Those are the 4 kinds of lines there can be. So how can you tell just by looking at an equation whether or not it's going to be a line? And the simplest way to answer that question is, it's a line if nothing weird is happening to the x. Now, what do I mean by weird? Let me give you an example of something that's not weird. I'm going to put this in the linear column. Something that's totally normal for x would be a problem like this. That is a linear equation because the x is being multiplied by 5 and that's it. Okay? Here's an example of what we call a non-linear function. And this, you said U-shape. This one would be a U-shape. The x is being squared. This graph right here makes a U-shape. That is not linear. Okay? This one, oddly enough, also linear. Oops. Y equals negative 2.3 is linear. There is no x in this problem. When there's no x at all, that's what makes our completely flat line. And while we're on the subject, this one's also linear. And that one, there's no y. If there's no y, that's a straight up and down line. Okay, let's put another one in the nonlinear column. There we're taking the square root of x. This one, if I graphed it, would look kind of like that. Sort of a goofy one. I really like the graph. This is not linear, but I like the graph of the absolute value of x because it makes a V shape. That's a cool one. Okay. That one's linear because all I'm doing to the x is multiplying it by a number. I can multiply x, divide x, add or subtract. If you do anything weirder than that, it's not linear. Add, subtract, multiply, and divide numbers, totally fine. Anything else, not totally fine. Let me give you one more non-linear one. This one also is pretty cool. That one looks like that. Little snake graph. That one looks pretty cool. Most graphs are nonlinear, and you will get introduced to the wide world of nonlinear graphs next semester. But for now, my apologies, linear only. We're going to stay boring. Sorry about that. Cool, so let's graph them. I'm going to kind of ease you in here at first. I'm going to give you a bunch of the tools that you need to graph these. So let's start off with our equation. X minus y equals 2. Eventually, I want you to be able to just take that equation and graph that exactly like it's written. Okay, that's our goal by the end of the evening is that I give you that and you give me a line. Okay? Not quite there yet, so I'm going to give you a little bit of extra information. One of the things that you need in order to graph a linear equation is some ordered pairs. I need a handful of points to put on the graph. 2, as I said, is the minimum. If you have 2, you can graph it. I'm going to recommend 3. I'll explain a little later why I recommend 3. It's not just because I love it when you do extra work. So I'm going to start you off by giving you a little bit of information. When you write down the ordered pairs you need, we sometimes create what is called a T-chart or an XY table. Create something that looks like this. I told you I wanted 3 coordinates, so I'm going to go ahead and make 3 spots on my T-chart here for the 3 coordinates that we're going to do. We're going to put the X coordinate on one side and the Y coordinate on the other. I cannot stress this enough. Eventually, you are going to do this all from scratch, beginning to end by yourself. But for now, I'm going to fill in a little bit of the T-chart. I want you to have one coordinate with an X value of 3. I want you to have one coordinate with a Y value of -2. And I want you to have another coordinate with an X value of -1. Okay? I'm just giving those to you. Those aren't special numbers. I just made those up. But I'm going to give them to you to get you started. So how am I supposed to use that to graph it? Well, it goes back to these problems that we did just a few minutes ago where I gave you the X or I gave you the Y and you had to figure out the missing piece. We're doing the same thing here, except it just looks different. Instead of me giving it to you in the parentheses like you're used to, I'm giving it to you in the chart, but same idea. If a coordinate had an X value of 3, what would the Y value be? Well, let's figure it out. This is X minus Y equals 2, and I'm telling you the X is 3. So instead of X minus Y, I'm going to do 3 minus Y equals 2. All right, algebra experts, what do I do? I think that's a good idea. Take away the 3. Can't argue with that. What's this going to leave me over on the left side of the equals? A negative Y. Good. Don't forget the negative. And on the right? 1? Are you trying to make me cry? -1. Very good. I got one more thing I got to do. What is it? Yeah, I got to get rid of the negative. How do I do that?
Add Y to -1.
I could add, okay, yeah, so I could add Y to both sides, and then I would have to add 1 to both sides so that the 1 was moved over. That is perfect. Definitely one way you can do it. But there's a way I can do it in one step. So what should I multiply by? How about -1? If I multiply this side by -1, what's -1 times -y? Positive y. And if I multiply by -1 on one side, I got to do it on the other. -1 times -1 is +1. So if the x is 3, the y is 1, that's my first coordinate. Okay. 1 down, 2 to go. Okay. The y is -2. What's the x? Okay, so back to our equation, x minus y, but it's going to be x minus, and the y is -2, and it equals 2. Minus negative, I can turn into plus. Good. Then what? -2, good. What does that leave me with? X equals 0. So, if the y is -2, the x is 0. That is enough for me to graph it. I've got 2 points, that's enough. Let's go ahead and do one more though. Let's do the -1. So instead of x minus y, it'll be -1 minus y. I promise in just a minute I will explain to you why we're doing this extra work. It's not just for fun. +1, good. That is a great plan. What does that leave me with on the left side? -y equals, okay.
Times 1 on both sides?
Times -1, yes sir.
Yeah, -1.
Yep, you got it.
Y equals -3.
Times -1, does that mean you're doing that with the y being negative?
Yes, I'm multiplying by -1 because the y was negative. If the y was positive, I would just stop.
Does -y is worth the value of 1?
Right, it's because -y times -1 is positive y. But if I multiplied the left side by -1, I have to also multiply the right side by -1. Okay. So now we've got 3 points. Here they are. We've got 3 ordered pairs. Let's graph them. So go ahead and get your graph paper back out. And I'm going to put those 3 dots on my graph. So I'm going to do 3, 1 first. So remember, from the origin, we count 1, 2, 3 to the right and 1 up. There's 3, 1. Zero, -2 is going to be where?
Down below.
Down which quadrant?
No, it's on the XY axis.
It's on the y-axis. Good. I was trying to trick you, but you're too smart. And then -1, -3. Right there. There's my 3 points, and you can see where the line's going to be when I connect those 3 points. Like you can just see, connect those and it's going to make a line. Why did I ask you to do 3 coordinates instead of 2? Here's why. If you only do 2 coordinates and you mess up on one of them, you will still be able to draw a line through them. If you do 3 coordinates and you mess up on one of them, you will realize you messed up because the dots will not be in a straight line. You'll have one here and one here and one way over here. And they won't be in a straight line. You won't know which one is wrong, but you will know one of them is wrong by doing 3 coordinates. If you only do 2, you'll always be able to draw a line through them, even if you're wrong. So I'm going to take my ruler here, and I'm going to connect these dots like so. Now, what does it mean when I connect these dots? I mean, yeah, I'm making a pretty shape, a line, but what does that line mean?
Give you all the solutions for the numbers that are along those lines.
Exactly right. That line represents every solution on that line. I only put 3 dots on here. I put 3 points on there until I drew the line. This looks like a line. It's not really a line. That is a million bajillion dots, all really, really close to each other, each one representing a solution. So like this point right here,
So
whatever coordinate that is, if I plugged that into the equation, it would work. That would be a solution.
will there be, on the deal, will there be where they said, hey, find that solution, like, you got all those solutions, and then it'll say, like, what other solutions are there?
Sure. Yeah, there's an infinite number of solutions.
Okay.
If you start counting like fractions and decimals and stuff, there's as many solutions as you want. Now, I had to stop when I got to the ends here because I ran out of graph space. But that's not the end of this line. The line would keep going if my graph was bigger. So the way that we indicate that is by putting arrows on the end of the graph. The arrows on the end of the graph say, this would keep going if I had more space. But I don't have more space.
Kind of like the absolute solution.
I don't know what that means. Can you elaborate on that?
It would mean if your graph paper was bigger to infinity,
Uh-huh.
the solutions that those would match up with should always be correct.
Sure, yeah.
Equation.
That is literally what those arrows mean. It goes to positive infinity and negative infinity along the x-axis and positive infinity to negative infinity along the y-axis. That is every possible solution that is on here.
Will they give you the graph and then say, is this a solution or not a solution?
Sure, you could. You could get the line and say, is 0, -2 a solution? If 0, -2 is on the line, the answer is yes, it is. And if 0, -2 is not on the line, the answer is no, it's not. Okay, let's do another one of these. Set your graph to the side. We won't need that till the very end.
Fractions?
Hey, that sounds good. You took the words right out of my mouth. How about some fractions? Oh, don't get mad at him. It was coming anyway. There was no avoiding the fractions. Don't get so scared about. First of all, fractions are not that bad. And second of all, you got a calculator. If you're that scared of them, use a calculator. Okay. So the first thing that I'm going to do is make my T-chart. I want you to have 3 solutions. So I'm going to go ahead and put 3 blanks here on the T-chart.
And this is just all simply just graphing one, right?
This is graphing a line, 100%. All right, and I'm going to make up some numbers again. Let's do one with the x is 6. Let's do a y of -3, and let's do a y of 0. I cannot stress this enough. There is nothing special about those numbers. I just made them up. Now, when I made up the x, I picked a multiple of 3 because I know I'm going to have to multiply it by a third. So I picked an x that I knew would be easy in this equation, but there's nothing special about 6. I just made it up. You can pick any point you want. We try to pick low numbers because we want them to fit on the graph, but you can pick whatever you feel like. If you had a giant sheet of graph paper, you could say, I want my x to be 694. You can do it. You will not enjoy it, but you can do it. Okay, so let's do the x first. X value is 6, so I'm going to take this equation and replace the x with 6. So it's going to be y equals -1/3 times 6 minus 2. What is -1/3 times 6?
18.
How about
8, 6. Wait. 6
I still have not heard the correct answer.
18
-2. Very good. It'd be 6/3, 6 on top and 3 on bottom, which is 2, but it's a negative times a positive, so negative. And then minus 2. So y is -4. Well done.
So negative 1/3 times 6. How do you get that? How do you get -2?
So if you have a fraction and you're multiplying by a whole number, you do the whole number times the numerator. So 6 times 1 divided by 3.
Oh, okay. I was the opposite. I was thinking 3 times 6 divided by -1.
If that mixes you up, and it's a common mistake to make, you can put the 6 over 1, and then you do 1 times 6 and 3 times 1.
Okay.
And you can do it that way. That helps you.
6/3, which is divided by 3.
Exactly right. It's 6/3, which is 2. And then it was a negative times a positive. Okay, let's try the one where y was -3. So this time I'm going to do -3 equals negative 1/3 x minus 2. Gonna have to do some algebra here, I'm afraid. Okay, good. I hear a couple of people saying +2. That's a good idea. What's that gonna leave me with? Negative 1 equals negative 1/3 x. Good. Times 3 will get rid of the 1/3, but I wonder if you can step up to the plate and get rid of the negative at the same time. Is there a way I could get rid of the 1/3 and the negative?
Times
Times negative 3?
Yeah, how about times -3? That's a good idea. You can multiply by 3 and then multiply by -1. That's totally fine. But we're gonna be real math experts here.
3 equals
Negative 1/3 times -3 is 1, so just x. So 3 -3, that's another point. So far, so good. I got one left, which is y of 0. Let's try it. So y equals is going to be 0 equals negative 1/3 x minus 2. Add 2, that's a good idea. Man, y'all are good at this. Your algebra skills are strong. You must have a ridiculously good-looking algebra teacher. 2 equals negative 1/3 x.
No, this time there's no negative.
There's not?
Yeah, there is.
Negative 1/3, right?
Right, that's the one I want to get rid of, is the one attached to the x. I'm going to times -3 again. Man, it seems like it's way more work when I have to plug in the y instead of plug in the x. Oh, man. I think when I get to make my own t-chart, I'm probably not going to pick y's as often as I'm going to pick x's. So -6. 0. And now we have enough to graph it. So back to our graph here. And I'm going to go ahead and put those 3 points on there. So 6, -4 will be the first one. So starting at the origin, count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's 6, -4 down there in the fourth quadrant. 3, -3, also going to be in the fourth quadrant. And finally, -6, 0. 1, 2, 3, 4, 5, 6, 0. And the benefit of having those 3 points is that before I start connecting dots, I can ask myself, are those dots all in a straight line? If I put the ruler on there, do they all line up? The answer in this case is yes, which tells me that these 3 points are most likely correct. The only way these points wouldn't be correct is if I messed up on all 3 of them, which is...
It almost looked like it didn't line up, but...
Because the other one was so far away?
Like,
Yeah, yeah.
That's why you say you want to do 3.
I want to do 3, yes sir. Am I done? No?
Put your arrows.
I gotta put the arrows on the end. That is exactly right. There we go. All right, you ready for the big ones? You ready to go from beginning to end all by your lonesome? I see a lot of people shaking their heads. I'm going to assume in your culture that means yes. Several people edging towards the door. I'm going to assume that is a sign of respect. So this is our ultimate goal here. This is what the problems will look like. And the directions will be graph it. These are the big ones. So when you see one of these problems and the directions are graph it, just because you aren't given the t-chart doesn't mean you don't need it. It just means now it's your responsibility. I still have to have points to graph it, so I'm still going to start with the t-chart. I'm going to do x, y. Only this time I'm not going to give you any of the numbers. You can pick anything you want for x or anything you want for y. You cannot pick anything you want for x and y because then you're just making up points. But you can pick one or the other. I don't care. Somebody just shout it out. Give me a value of x or a value of y. I don't care. Just shout out a number.
4.
4, is that going to be an x or a y? X? Okay, great. I'm glad you picked a small number. We want small numbers so they'll fit on the graph. 2 is for y. Okay, great. And negative what?
12.
Negative 12. Negative 12 won't fit on the graph.
That's just counting. The 12 lines.
Negative 6.
Really?
Yeah.
Okay.
Are you sure?
No.
Negative 6.
1, 2,
Negative 6 for x or y.
X.
Are there 12 in both directions?
Mhm.
I thought I just went to 10. I thought I just went to 10. If it goes to 12, be my guest. Cool. Now what?
I'll say that.
Now I got to plug them in and do some math. Okay? So the first one I got was x equals 4. So let's go right here. X equals 4. I would subtract. Subtract what? Subtract 4. Trying to get a diversity of colors over here, but I'm not in love with the pink. It's a little too light, I think. So negative 4 is what I ended up with. We're going to give pink its shot, but I'm not in love with it. Cool, one down. Okay, great. Let's do that one next. X plus 2 equals 0. What do I do? Subtract 2. Good. So x equals negative 2. Great.
Looks like their sequence are just opposite.
It does look like that. They're just the opposites. Now, why would that happen? Well, because the equation was you add two numbers and the total 0. Yeah, exactly right. So what do you think y is going to be here? It's going to be positive 6. Excellent observation. You just saved us a little bit of time. Yeah, it makes sense they'd be opposites because the equation was when you add them together, you get 0. All right, let's go to the graph. And let's put the 3 points on there. So I got 4, negative 4. Which quadrant will that be in? Fourth quadrant, good. What about negative 2, 2? Where will that be?
2.
Second quadrant, good. And then negative 6, 6?
Second.
Second quadrant, upper part of the second quadrant. Good. And then let's connect the dots. And there it is.
Well, I might be going ahead of myself, but you know how they'll say to graph 2 lines and then find the intersection?
Uh-huh.
Is that going to be on the deal?
It's a few weeks from now, but we're going to do it eventually.
Oh.
You got a few weeks to go. What you're talking about is systems of equations. What he said was, what about when you graph 2 lines and see where they cross? We are going to do that, but it's going to be a few weeks.
Unlock it. Unlock it.
You ready to do it right now, huh?
I remember this. This is fun.
All right. I want to give you kind of a weird one.
That turns into y is a 0 or the negative 2?
Hmm?
That turns into y.
Yeah, where's the y? That's a good question. Well, we're still gonna make our
2 is what?
chart here. All right, pick some numbers to plug in. 2. What's that gonna be?
Negative. Y.
Where are you gonna plug it in?
Never mind, X.
It's got to be x because there's nowhere for me to plug in y. So you said 2, right? Okay. Give me another one. 4
5.
and 5. Okay, great. Okay, let's plug it in. So instead of x minus 2, I'm going to have 2 minus 2 equals 0. So when I combine these, I get 0 equals 0. What's y going to be?
0.
There's no y. That doesn't say y equals 0. It says 0 equals 0. What the
2.
heck?
So it's 2.
Y is 2?
Oh, wait. Hold on.
No, the answer is negative 2.
Uh-oh.
Where'd you get negative 2?
What happens when I plug in 4? 4 minus 2 equals 0 for this one. 4 minus 2 is 2. I get 2 equals 0. That's not even true. 2 doesn't equal 0. What is happening?
No solution?
There's no solution.
There is a solution, but the reason this one's weird, as of course you can obviously see, there's no y. If I were to solve this for x, meaning if I were to add 2 to both sides, I would get x equals 2. What this means is x equals 2 all the time. No matter what y is, x is 2. So if I were to make my t-chart, and I said, hey, make up a number for y, and you said 3, what would x be? X is 2. What if y was 7? What would x be? X is 2. What if y was negative 5? What would x be? 2. X equals 2 no matter what. So let's see what this looks like when I graph it. My first point is 2, 3. My second point is 2, 7. And my third point is 2, negative 5. Hey, it's straight up and down. When you do not have a y in your equation, when it's just x equals a number, this is always what it looks like. It's a vertical line, just like that. What do you suppose it is when it's y equals a number?
I mean, we're horizontal.
It's horizontal, and if you go back a few pages in your notes to when we talked about linear equations, I said there's 4 things they can look like. They can go up, they can go down, they can be flat, or they can be straight up and down. This is when it's just x equals and there's no y. This is when it's y equals and there's no x. That's x equals a number, and this one is y equals a number. And so this one, there are no x's in the equation. This one, there are no y's in the equation. Okay?